let's get started now. And we're not the only ones responsible for this. So I'll show that later. Yao Tong is here today. She's at VU Amsterdam, and she provided most of the data that we're actually using for this open data set. And Elizabeth Mahoney, who can't be here today, that's why I'm going to show an image of her, did a student project on ways of releasing this data set. So the idea is to briefly talk about open data sets, then introduce Newscape and the distributed little hen lab, although many people here probably know that, and then talk about the red hen interview gesture collection, the manual annotation, our attempts at working around copyright issues, and providing baselines, and that is where Swadesh then takes over. Now, if you like, open data sets are the rocket fuel, at least if you pick up what Mark Turner last week said in his talk, that if machine learning is the rocket, then data are the fuel. And open data sets are exactly what science needs because, of course, they lead to reduced costs for data collection and curation and allow us to do comparable research via, for instance, shared tasks. That is something that's very common in computer science. You basically want to see whether the computer can find cats, and therefore you provide it with lots of images, and human annotators, like say crowdsourced via Mechanical Turk, for instance, will say there's a cat in that image or not, and then you'll train the computer to recognize that. Usually this comes with baselines. That means like the most basic or a relatively basic automatically annotated approach, so that anybody who tackles this project knows that like they have to beat that in order to have something worthwhile. But not only in the computer science world, also in it's relevant in terms of reproducible research. Everybody's aware of the replication crisis that we have, and part of this is because people don't have access to other people's data. They can't really replicate. And with open data sets, this becomes much easier to do. Now, as I said, it's common in computer science. That means usually also in its subdisciplines and in related fields, computer vision, computational linguistics, and so on, but also in completely other areas. Sociology is common, where people have data sets, shared data sets. Genomics, the Human Genome Project that is publicly available via the GenBank, is something that comes to mind. And there's lots of data sets you can find, for instance, if you go to Kaggle.com, which is a machine learning community that collects data sets. Now, all in all, we could say that open data sets are a major driving force of scientific progress. Now comes the but. Thing is that this trend only has reached some areas in the humanities, and most data annotated by experts in the humanities still sits on these experts' hard drives. So for our purposes, we're interested in multimodal communication, in particular in co-speech gesture. That is quite common, that people do their analysis, publish about it, and then that's it. It's the data set cannot be reused by anyone else because people don't have it. Now, in order to resolve these things, it's of course possible to use existing open data sets or existing not so open data sets and try to make them open. So we'll talk a bit about Newscape and Red Hen, because that's a lot of data, multimodal data galore I wrote here, to basically give you an overview of what happens there. The UCLA Library Broadcast Newscape is an archive of TV news. They started in 1973 with Watergate hearings on magnetic tapes, and soon started recording the major US TV news, plus some local LA market data. Now, the magnetic tape stuff is data that is partly digitized. There's a major project going on at UCLA, but most of it isn't, and it doesn't come reliably with good subtitles, which is a bit of a problem for us. In 2005, 2006, Francis Dean transitioned the whole project to computer recordings. And then from 2012 onwards, with the support of mainly Mark Turner, it was extended to international data. And there's a worldwide recording stations network. There are recording stations in Germany, in Brazil, in Egypt, in Spain, you name it, there's quite a few of them. Now, a data set like this, an archive of this type, is, of course, by definition, relatively closed, because you can't just share anything you record from TV. But in the United States, there's an exception, and that is Section 108 of the US Copyright Act that states explicitly, an archive is allowed to record television news and lend out copies. Now, the wording already may indicate it. This is something that has not been tested in court recently. This is something when lending out copies was you go there and take out the magnetic tape. That's from that time, this clause. Also, the definition of television news, there is no universally accepted definition of that. There is hard news and soft news. So is something like a daytime TV talk show, is that television news or not? Some people would say, some people won't. Now, Newscape actually takes a relatively wide definition and thus currently records about 150 shows a day, and about 120 of those are in English, mostly from the United States, of course. All the data is annotated on multiple levels, and it's the basis of much of the research done by the Distributed Literate Hen Lab, to which I'll come in a second. Now, for our purposes, it's important to note that basically, if you are a user of the archive, you're allowed to get copies of television news. But this doesn't necessarily mean that we can share it. We're not allowed to share the data in its entirety online or something like that. And also, it doesn't necessarily mean that even users get access to all of it. That's often not good enough. If you want to have a really open data set, that of course doesn't work all that well. Now, the Distributed Literate Hen Lab is a global cooperative of researchers working mainly on multimodal communication. And because it's a cooperative, it's not owned by any individual institution. Basically, it's there, and I quote from the website, to connect scholars with different resources, skills, etc., to address the challenging research questions of multimodal communication. Now, Red Hen is directly related to the Newscape dataset. People work a lot with Newscape data, but it's not limited to it. And one thing to understand is really it's a cooperative, it's not a service provider. It's not like you go to the people in Red Hen Lab, which is, by the way, directed by Mark Turner and Francis Dean, but I'm a member. If you can't like come to me and say, I need this, and I say, yeah, no problem, I'll do this for you. Not necessarily. You have to work with this data yourself. Now, we're devoted to open source. We have been in the Google Summer of Code 7 times now already. And that is also what we're going to, one of these projects that we're going to present today. And Mark Turner once likened it to using an image from software development, likened it to a bazaar and not a cathedral. What does that mean? Well, it means that there is not like one general architect that says, we're going to design it this way, and we're going to have this over there, and somebody knows what it looks like. It's basically people working together in various configurations, and it still somehow all works. Now, the most important aspect for us today is that Red Hen is a sort of gift economy, or has a sharing culture. If you annotate data, you're expect to share it with other Red Hens. So I quote again from the website, If you access Red Hen data to create a tag dataset for your research, the default expectation is that you will return to Red Hen a tag dataset useful to others interested in doing such work. Typically, this dataset will be released as an open dataset. So far, the idea. Now, the problem is, again, copyright. We can't share the actual primary data. We can, of course, share the annotations, but we can't share the primary data as easily. And how do we actually work around this? Well, that's what we're going to talk about in a second for the Red Hen interview gesture collection. But first of all, I'd like to briefly say something about this data set. So it's manually annotated data, and one thing you have to understand is that manual annotation in gesture studies is extremely time consuming. So we have interview segments from the Ellen DeGeneres show, because that has been shown to be really good for gesture analysis. The camera angles are so that usually you can see the people's hands, and there's interview segments that are interactive and therefore quite helpful. And so these are roughly 10 minutes each on average. Some are shorter, some are longer. And they're annotated in Elan. That's a piece of software specifically used for annotation of multimodal data. I'll show an example in a minute. Now, the data that we're using here comes from 2 PhD projects at the Vrije Universiteit Amsterdam, supervised by Alan Schenke. The first one was the PhD thesis by Sui Wu. She annotated roughly 10 of these 10-minute interviews and did extremely detailed annotations. And the second data set comes from Yao Tong, who is here today. And she, for her PhD, annotated more than 30 videos, also building on top of the ones by Sui, but with much less detailed annotation because, well, she has different research questions for that. So what does this thing look like? Well, this is an example. This is the annotation screen in Elan. This is one of Sui's annotation data files. You see here the video window, and you see here the different levels of annotations, layers, or whatever you want to call them. In Elan, they're called tiers. And you see that Sui here, for instance, coded gesture phases. So we have the stroke, a hold, a retraction phase, stroke, hold, preparation, stroke, hold, and so on. You get the idea. And for each of these strokes, which is sort of the main part of the gesture, we have annotations on multiple levels. So we see it's left-handed, hand shape 1, 2. That's the thumb and the index finger. Orientation, palm lateral, T, and then there is something I think not visible here. It's either palm lateral towards center or toward body or something like that, if I record it correctly. Location, center, periphery, movement type. Is it straight or is it arced or in circle? Direction of the movement. You get the idea. Type of gesture. It's extremely detailed, and doing this takes ages. Now, it would be a complete waste of time to have this just sit on, well, it's not a complete waste of time, but it's inefficient to have these sit on the researcher's hard drive till the end of the PhD thesis, and after that, nobody needs it again. Maybe they need it again for some other project. I'll just play this for a second so you can see how the annotations here link to the video.
Mickey Mouse doesn't come out that often, just so you know. You don't walk around Disney. He only hangs out on Main Street. He's not like running around accessible. He's a celebrity.
Okay, you get the idea.
Mickey Mouse.
Now, the problem again is this is copyrighted material. We need to do something about this. And so we came up with 2 approaches. One is to use freely available data. Freely available data doesn't mean that it's like everybody can give it to everybody, but you can get it, the user can get it from, for instance, YouTube, or actually EllenTube. Did you know there's an EllenTube? It's basically Ellen DeGeneres' website, which has lots of videos of her interviews on there too. And then we would just provide the annotations together with instructions on how to get the data. And that was a student project by Elizabeth Mahoney. And she, for every one of these 30 videos that we're interested in, so we had have a total of 30 videos in the manually annotated collection, not all annotated to the same detailed level that you just saw. Most of them aren't actually. But with that student project, we gave Elizabeth the 30 videos, and she went on and searched. And she found that not all the interviews are on YouTube, but a sizable portion. It was something like roughly 20. Swadesh has the exact numbers in his presentation later out of the 30. But the whole thing is problematic. It's unstable because sometimes videos on YouTube are deleted and just disappear. Users are banned, things like that happen. And that means, of course, when the point is replication or data sharing for something stable, it's not all that reliable. It also needs exact timestamp matching, but we have that sorted. We're using a tool called YouTube DL, and Swadesh will show the syntax later. Now, that is something that we sort of have resolved in a way by saying, okay, we can share this based on freely available data. It's a smaller data set then, but it's something that people can use, and we are not on the hook for sharing copyrighted data. The other approach is to actually share the annotations and derive data. If the data is not the original data and can't be used like that anymore, then we have a way of sharing it. So one way is to use what is called Openpose key points. We saw that last week in the presentation by Mark and Yash, but also later on in Swadesh's presentation, he will show what these key points look like. It's basically a computer-generated skeleton. So a computer vision software, Openpose, looks at the video and describes a skeleton, and that would be all that we share. That can be used for machine learning, and that's a slightly different task than gesture detection, because the computer vision community, I had the feeling some people were even sort of, no, that's not computer vision because we're only working on these key points. So it's a slightly different community that does this kind of machine learning. But it is something that would allow us to share the data still in a useful format for other people to come up with cool computer models. And in order to have one of those cool computer model as a baseline, that we decided to have this Google Summer of Code project that Swadesh is now going to tell you all about.
Very good evening to everyone. I'm Swadesh Jana, and I'm from Erlangen-Nuremberg, Kolkata, India. I am currently in the third year of my undergraduate studies in computer science and engineering, and I participated in the Google Summer of Code 2021 for automatic gesture annotation, which I'll be speaking of in a minute. So the contents, we can skip this introduction. So basically first I describe a bit about the problem that we have. So we have, as my mentor Peter said, that they're manually annotated data set of videos and therefore gestures. So we need to understand what is a gesture. So a gesture will be a specific movement of arms during speech. Say, for example, I'm moving my arm while explaining to you, then that is what a gesture is. That is, it is linked to the speech in some way. And also the thing to be noted is that it depends on the continuous passage of video frame. So basically, if I did something like this, or maybe possibly this, a thumbs up, then you could actually capture one frame where you would find that I have such a pose, and then you would know that there's a gesture. But this is not something like that. It depends on video, on continuous passage on the video and not on an image. So that's one level of difficulty. And as marked on the Elan software, we can also have left, right, both hands, left, right, both hands, and so on and so forth. But there are very few for us. The basic goal is to develop a relevant pipeline using deep learning methods and modules to identify such gestures. And we can at least have a list of start and end timestamps, so that you know that from here to here there's a gesture, then from there to there is a gesture. So that is something that will be provided by this pipeline. data set, this has been talked about. So on that list of 30 videos, 19 were accessible from YouTube and other platforms. 3 were found to be private and 8 were not found. So I guess you can skip this one. Yeah. So YouTube DL, you can just go here and download the package on the command line. It is on the terminal. You can just write YouTube DL, then space, the link to the video. It can be a YouTube link, then -o, the file name that you want it to be saved as on your computer. So this will work fine, and YouTube DL will download the video for you. And then you annotate using Elan. So that is also there. And since this was a coding project, so it is very relevant to speak about the environment. So I got access to the Case Western HPC cluster, and I was provided with GPUs, there's Tesla K40s, P100s, and RTX 2080, and similar kind of GPUs. I worked in Python version 3.6, and I utilized TensorFlow and Keras. TensorFlow is version 2.1, so Keras is inbuilt inside TensorFlow after the version 2. And also I use NumPy and Pandas libraries for working with arrays and CSV files. I'll be speaking about that in the further slides. And I was required to use Singularity because say I have a number of code files, and these code files are heavily dependent on the environment. Say I require TensorFlow version 2, then I require all those libraries, then I require CUDA support. So it will be very difficult if I just tell you all that and then ask you to install it on your computer. So instead of that, what we can do is that we can have an image file that is for Singularity is called an SIF file. So that SIF file, it will be large because it will be containing an OS, all the libraries inside it. So it will be say about 4 or 5 gigabytes, that kind of, it will take that kind of storage. But you can just take it to your server, you can take it to your computer and just run it there, and it will run fine. The pipeline. So first I'll be talking about the pipeline, what we are going to expect. So if you just input a video to the module, first there will be an Openpose inference, which will give us some key points. I'll be talking that in the next slide. So these key points are for each frame, and I'll use these key points to arrange them in relevant way so that I can pass them through a model developed on TensorFlow. That will be a time series model, and predict whether there is a gesture in one of the frames. So in every frame, I'll just identify if there's a gesture or not based on the data from the previous frames. And the output will be a video marked with gestures and also a CSV file. So Openpose, and you can go to this link and find out the code, and you can also make a module for yourself. So what does Openpose do? As you can see here, I have given the image for 25 key points that it identifies, but there are like many sort of ways that you can use. So you want to detect the fingers, then you can also do that, but I didn't require that. So I have used this one, and as you can see in one such video, they are all marked out. These two are live human beings as an image, but Openpose also identifies this human. And how it does that? So there's a concept of part affinity fields. I'll not explain it in detail, but basically what it does, say for example, for this person, it identifies the eyes, nose, the neck, and it tries to build these edges. So because it doesn't know if these edges are true or some other edges, so the eye is here and then neck is here, it doesn't know. So it tries to give probabilities to these edges, and it tries to predict which one is the correct one. So that is how it finds all the key points. And next, we use these key points in our prediction module. So firstly, we'll discuss about some issues with the key points. So basically what happens is that when we get the key points, they are per frame. So like there's a file for each of the frame, and there's marks like human one, so person one, these are the key points, person two, these are the key points. And let's say in the next frame, it says person one, these are the key points, person two, these are key points, but it doesn't say whether the person one in this frame is the person one in this frame. Possibly the angle has changed to somewhere else. And there's another person one. So Openpose doesn't give us any idea of that. So there can be different number of persons, there can be different camera angles, and the coordinates of persons are not linked across frames. It just treats each of the frames as an image, and it tries to find if there are any persons or there or not. So we thought of an intuitive solution, and what we are trying to do is we are dividing, or we are grouping the frames based on the following criteria. So there are two criteria: the number of persons and the change in angle. And say, for example, from 0 to 100, it was pointing at some angle, and from 101st to, let's say, 200th frame, it is pointing to another angle. Now what the problem will be is that, let's say I take the 100th frame key points and I have 101st key points, but these are not linked. So my model will not be able to identify that. And then it will not be able to predict correctly. And that will lead to erroneous data. So the grouping is very important. And how am I doing it? So since most of the talk shows have persons sitting and they are at rest most of the time, so I am approximating the person by a neck key point, and I am trying to find out what can be the maximum error that can be there between two frames. Say, for example, there can be 10 pixels, 20 pixels, that can be the maximum range in which there's an error, or possibly the person is moving. And so if that is within that range, then that is the same person across two frames. If not, then these are two different persons, and that means the angle is not matching, or the angle has changed. And predictions are all made only within these divisions, as I said. And yeah, so for example, I am now taking the 100th frame, the 101st frame, and the 102nd frame. Okay, so I should say that 101st frame in the starting. So 101st frame, 102nd frame, and 103rd frame. And I'm using all the three key points to predict whether there's a gesture in the 103rd frame. You can just understand that. Let's say I'm moving my hand. So in the first frame, it does my hand is here. In the second frame, my hand is here. And the third frame, my hand is here. So as you can see, it has moved, and the model is able to identify if there has been a movement. But again, it has to be linked to speech, and not, it cannot be like I'm just rubbing it on my hair. So that is not the gesture, right? And also we considered only neck, shoulder, elbow, and wrist coordinates for our model, and it works well. I'll also show the output in the later slides. Okay, so this is going to be a bit of technical and related to computer science. So I will try to explain it as simply as possible, because I know that some of the audience are not well versed in computer science. So what I'm trying to do is that I get the key points. Now I arrange them as such that say this is the person one's key points: neck, wrist, elbow, hand. Then we have the key points here for person two, then person three, and so on. And say this is one frame. So say this is the 101st frame. Then I'm saying this is the 102nd frame. This is the 103rd frame. That's how I'm arranging these frames. And then these are input to a TensorFlow model. And so this is a three-dimensional data. As you can see, there are three dimensions to this. And there are two layers particularly which help us to train the model, and that's Conv3D and Conv-LSTM 2D. So Conv3D is a 3D convolutional layer that multiplies 3D kernels on each of these axes and trains these kernels. So basically, what is a kernel? The kernel will be, so let's say this is a large, what should I say, a large three-dimensional data, and I take a kernel, let's say of size 2 cross 2 cross 2. So that is 2 this side, 2 this side, and 2 that side. So 2 on each of the axes. and I multiply this kernel with this data and get a value. So I'm trying to optimize my kernel to get such values so that I can predict well. And what is conv LSTM2D? LSTM itself is a very, what should I say, a topic in its own. So I'll leave that. And what conv LSTM2D does is that it trains conv 2D layers. So 2D means these two axes, and LSTM is working on this axis. So I'll continue with this much information. And this is a model architecture that I am using currently in my model, and I won't dwell much on it. We can discuss it in the question answer session if required. And I guess it would be well to show you this video where I'm marking hand gestures here, and you'll see. Oh, also I should mention that we trained on the LN videos only. So this is a new test video, and you can see the results.
He has in the channel, and his remote balance is my balance. So in every payment channel, there's two balances. Think of it as a pile of money sitting on one side of the channel and a pile of money sitting on the other side of the channel. When we opened this channel between us, because I funded it into the multi-signature address with a transaction, the money's all sitting on.
So as you could see that in at one time stamp, it missed the gesture. So obviously the model is not 100% accurate. We also know that we are training it, and with more and more data, obviously it gets better. And also you also get a CSV file, as you can see the format in which the CSV file will be present. So here it's marked, but if you want, let's say, the exact timestamp or the exact frame number, so you can always refer to the CSV file and find out where, if there is a gesture or not.
He has in the channel, and his remote.
Sorry about that. Yeah, sorry. So the usage, basically, the model is inside a singularity container. So if you want to use a model, you can just run any of these, what should I say, any of these command line instructions. There's many more ways you can do that. You can specify the parameters, you can choose not to specify the parameters. All that is written here. I'll explain one of these so that you get the context. Singularity, that is a module that we are using, run --nv. This is a GPU access. So I'll want the GPU access because it's a computer vision problem. Openpose is working on the videos, and it takes a little bit of time if it is working with CPUs. So GPU access is required. -b is bind the main directory to it, then the gesture file, the SAA file, and then we can have --input dir or --input files. So I'll mention all the files or the directory, and it will automatically find all the videos in there. So in the output directory, I need to mention the output directory where we will use to write all the data that we want to, and then train parameters, or here detect similarly. So that is the how you can use it. And yeah, also for training, we require you to provide the videos as well as the CSV files. So what is this CSV file? This CSV file is actually for the training data. That is, we need to know when is the starting gesture and the ending gesture times. As you can see here, begin time msec and end time msec. We need to know these in the video so that we can train the model. For detection, only video file will suffice. Output files, I'll not dwell on this one much because it's just, I have just listed out all the files here. You will want this file and this file. So this is a CSV file, and this is the output file that you want, a gesture level output file, and this is the file marked with the gestures. So there's a CSV file. Analysis, so we used, the current model largely uses conv 3D layers. So I replace the conv 3D layers with conv LSTM 2D layers, and here is what the output on the validation set. So as you can see here, and I'll remark that the accuracy could have improved, may not have improved, because these are manually annotated videos. So there can be possibly 1 frame error or 2 frame error that may not be recognizable by the eye, but that's get reflected in these values. So that kind of error is always there, but obviously it's always, we can say that is added, subtracted. So it might just, we can just rule that out as well. And also, for those of you who know, this also bidirectional LSTM 2D layers, sorry, bidirectional LSTM layers, but they do not work well, so we have not mentioned them here. And finally, we come to the future scope. So what would we like to do? Because we got only 2 months and 10 days, and in which we had to understand how to work with Singularity, how to work with HPC cluster, and so on. So with Openpose as well. So there are a lot of things that we have to do in the upcoming months. So it is not able to predict which person is performing the gestures, because there's a lack of data, as well as it is difficult to understand which person exactly is performing the gestures. We know that there's a gesture being performed in the way the data is, we have got the data. So that is something we want to work upon. And then the arm movement, type direction, all that you saw in the one of the videos that my mentor just now showed. And there's another limitation. This is related to Openpose. So let's say I am doing a gesture like this, then it will not identify my palm or my fingers, because it tries to find the whole body. So it will recognize my eyes, the neck, and then it has to find my elbow, my shoulder and my elbow. If it doesn't link my shoulder to my elbow, so it will not be able to link the hand to my body. So therefore, this won't work, and it can be handled by other modules, but they are not as accurate as Openpose. So we'll have to go for a trade-off there. And I guess that's it. Thank you for listening to me. And it's an honor to present my work. And here is a link to my blog, where I talked about what I did and how I spent the 10 weeks or so. And if you want my CV, you can just go to swadesh13.github.io, and there you can find my CV as well. So that's it from my side. Thank you.
Okay, thank you, Swadesh. And just from the Red Hen perspective, I'll just say a few more words. And that is, this was designed as a project to come up with a gesture detection baseline. Now it turns out that Swadesh's system is actually really good, and we're really thinking about putting it into production for our own data, because getting something like 78% accuracy is quite nice. There's one more thing that Swadesh briefly mentioned that I just want to point out, and that is that the requirements for annotations are, of course, slightly different for humans and for computers. So there's 2 things here that play a role. One is that the data set that we have is annotated for co-speech gestures. That means it's specifically not annotated for other hand movements that are not communicative, that are not co-speech gesture. And the computer vision, of course, doesn't know this. It will still see this as as something moving, which may result in lower performance. And the other thing is what Swadesh just mentioned: human annotators don't need to specify who is gesturing, because, I mean, they can see it. It's not a problem to detect it, but for the computer, that's an actual problem. All right, well, that's it from us. Thank you very much for your attention, and we're interested in hearing your questions and suggestions.